In this lesson, we want to talk about the conjugate root theorem. But before we start talking about the conjugate root theorem, we must first understand the fundamental theorem of algebra. The fundamental theorem of algebra was discovered by Claude Gauss, who we seen in the introduction or the history of complex numbers. He was the person who actually came up with the idea of complex numbers, joining real numbers and imaginary numbers together. But the fundamental theorem of algebra states that y is equal to x to the power of n. If we have that sort of an equation where n is the highest power of x, then that has n roots. So let's take a look at that a little bit further. So if let's say y is equal to x, that has one root. Y is equal to x squared, that has two roots. And it doesn't matter, let's say that if it's y is equal to x squared plus 7x plus 1, that also has two roots. And if you have y is equal to x cubed, that has three roots. So if you want to know how many roots an equation has, if you look at the highest power of n, that will tell you how many roots it has. So if we just take a look here, the highest power here is 3, and that is 3 roots. So that is the fundamental theorem of algebra. Now the conjugate root theorem, what the conjugate root theorem states, is that if you have roots, complex roots, and you have if a plus bi is a root, then a minus bi is also a root. And a minus bi is the conjugate of a plus bi. Just go over that again. So a plus bi, the conjugate is a minus bi. So let's just take a look at an example there. We'll just give ourselves a little bit more space. So let's take a look at the equation y is equal to x squared plus 1. Now if we try to solve this, we just put y equal to 0. We'll put y equal to 0 there. We'll have x squared plus 1. So what we could say now is x squared is equal to minus 1. Just switch things around there. And that means that x, when you solve it, x is equal to plus or minus the square root of minus 1. Square root of minus 1 is I, so we can say it's equal to plus or minus the square root of minus 1. So therefore x is equal to I or minus I. Now what I want you to notice here is that minus I is the conjugate of I. So let's take a look at another equation. So this time we'll just give it a bit more space. This equation is y is equal to x squared plus 2x plus 5. So let's take a look at the roots of this equation. So this is a quadratic, and we're going to use the formula to look at this. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. So it's better to just put down what a is. A is 1 in this case, b is 2, and c is 5. So if we put them into the formula now, we will get minus 2, which is minus b, plus or minus the square root of b squared, which is 4, minus 4 times a, which is 1, times c, which is 5, all over 2 times 1. So this, I will just go down to the next line here. We have minus 2 plus or minus the square root of minus 16 all over 2. So what we can do is we can take them, we can split the minus 16 up. So we'll have minus 2 plus or minus the square root of 16 times the square root of minus 1 all over 2. Now the square root of 16, so it's minus 2 plus or minus the square root of 16, which is actually 4, times the square root of minus 1 all over 2. And what we'll do now is we'll split that up, and so we'll have the 2 will go into both, so we'll have minus 1 plus or minus 2 times the square root of minus 1. So now the roots are minus, and we're going to replace the square root. We're going to replace the square root of minus 1 with I. So their two roots are minus 1 plus 2i, and the other root is minus 1 minus 2i. And what I want you to notice here is that this is a conjugate of this. So conjugate root theorem. This also has other applications in terms of if you look at let's say y is equal to x squared, that has two roots, but depending on the equation it can have two real roots or two complex roots. But it cannot have one real root and one complex root. If you have y is equal to x cubed, that can have three real roots or it can have one real root and two complex roots that are both conjugate pairs. They're conjugate of each other. So you can see that when you look at the highest power of x, you can actually tell, and using the conjugate root theorem, you can tell what type of roots you can have in these situations. So that will help when you're solving leaving cert questions.